inverse functions. Well, let's say we'll start with a nice one. They gave you, I don't know, 5x minus 1. And you wanted to find its inverse. Well, algebraically. Then we'll find it by graphing. If you want to find it algebraically, first replace the f of x with y, because you know it's the same thing. And then to find the inverse, you're always going to do two things. You're going to switch x and y, and then you're going to solve for y. So if I want to switch x and y, and now I'm going to solve for y just like normal. So I'm going to add the 1. So 5y equals x plus 1. I just switched it to make the variable on the left. It doesn't matter. You could have said x plus 1 equals 5y divided by 5. So the inverse of y, that's just notation for inverse, equals x plus 1 over 5. Let's say if I had y equals, let's do an interesting one. Well, we'll start with the square first, then we'll get to a cube. Let's say I gave you this and wanted the inverse. Well, switch x and y. Notice how this position still stays squared. It's not x squared equals y, it's the position. Now to solve for y, I'm going to subtract the 4. So y squared equals x minus 4. Square root it. So the inverse equals square root of x minus 4. Now technically on this one, now because the virus, we're not going to get too technical, but so it'll be on the same video. I'm going to come back to this one when we solve by graphing. So just let's keep it at that for now. And let's say one more. What about, we'll do a square root, x minus 3. Switch x and y. Solve for y. So notice how we can't just add the 3 with a square root. So we have to, square both sides. X squared equals y minus 3. And last step, to get y all by itself, add the 3. So inverse equals x squared plus 3. Now, there's also something else that we can do. Let's say it was something like determine whether or not they're inverses. And a way you can check yourself, we'll do one, then we'll come back to those. So if I said f of x equals 6x plus 3, and this equals, what do I want it to be? We'll say, 1 over 6x minus 3. Or actually, let's make it that. X minus 3 over 6. Yeah, that's what I want. We'll take off the understood one. So if I have this and I want to know are they inverses, you can do either this or the inverse of it. The inverse into the original. It doesn't matter. And if you get x, then yes, it's an inverse. If you get anything other than x, it's no. So let's plug in this in the original. So 6 times x minus 3 over 6 plus 3. 6's cancel. 3's cancel. You just get x. So yes, even if, let's say, prove this one, the one we did a minute ago. if I plug in the inverse in the original, so square root of x minus 4 squared plus 4, the square roots and squares cancel, x minus 4 plus 4, x, so sure enough it works. Even if I did, well, let's say this, what about f of x equals x squared minus 2, just to show you what this would look like, let's say square root of x minus 2. Well, notice how this one, if you plug it in, square roots cancel. You get x minus 4. So no, one of those should have been a plus sign in order for it to be a yes. Now, inverse by graphing, and then I'm going to come back to the graphs like I told you I would. If you want to find the inverse by graphing, let's say, I'll just graph it, do it again, the 5x minus 1. Graph the original, so down 1, 1, 2, 3, 4, 5 over 1. There's your inverse. Well, you can also find inverses. Let me show you this real quick. If they told you, if they just gave you a set of numbers like 2, what do I want? My mind just totally went blank. Looks weird like that. Where if they gave you like -1, 2, 3, 8, 4, 6, the inverse would just be literally switch the x and y. Remember the first step of doing it algebraically? And that's all you do. Well, that comes in handy when you're graphing, because we graphed the original first. Now remember, whenever we plugged in the inverse in the original or vice versa, we got x. Well, notice how if you were to graph the line y equals x, so with the origin over 1 up 1, that's what line that the inverse is going to reflect over here. Now the way you can draw it, notice how 0, -1 is on this graph. So if you think of inverses, on the inverse graph, it's going to be -1, 0, which is here. Over here, we did 1, and then 1, 2, 3, 4. So that means on the inverse, it's going to be, yep, you got it, 1, 2, 3, 4, 1. And when you connect your two dots, see how it's reflective on the x-axis. Let's go back to the other one we did, square root of x minus 3. Well, let's graph it. Right 3, swoop. So, if you want to find its inverse by graphing, do your line y equals x. See how on this one 3, 0, so you know on the inverse 0, 3. And this one, see how it's swooping, so you can just kind of eyeball. There you go. Let's go back to this one we did a minute ago. X squared plus 4. We know that's up 4. And a parabola. Well, here's the problem. And I know you're like, oh, well, that's simple. Just go right 4 and do a parabola. Well, the trouble with that, that's not a function. And so on if it's x squared, they'll say restrict the domain so it's a function. Notice how if you were to cut off this side, or if you were to say x is greater than or equal to 0, that would cut off this side, and it's a function. So there you go. And notice how squared and square roots are inverses. So notice how it's basically the same graph once you cut off the sides. Let's do one more, because this one's kind of interesting. It's x cubed. If you were to graph it, you know, it's just your basic swoop. Y equals x. So it is going to look something like that, which the inverse is just cube root. So that's why it's like that. Well, anyway, I hope that was of help to you. Have a great day.